Hello everyone. In this video, we will discuss about the ordinary general annuity and general annuity due, as well as perpetuities. As all of you know, that ordinary general annuity means the payments are done at the end, and the payment period and interest compounding periods are not same. Whereas general annuity due is the payments are done at the beginning, and the payment period and interest compounding periods are not same. So let's see first the ordinary general annuity. Now, since the payment period and interest compounding periods are not same, so first we will find out what is the ratio between that. So interest compounding period and the number of payments per year. So the C is the ratio of interest conversion period and the number of payments per year. Equivalent rate of interest we need to calculate to find out what is the equivalent rate, that is because the payment period and interest compounding periods are not same, so what is the equivalent rate of interest, so which can be calculated using this formula, and the future value of ordinary general annuity can be calculated using this, where PMT is the regular payment, P is the equivalent rate of interest, N is the total number of payments here, and P, equivalent rate of interest, which is calculated using this formula. Now, you can find the C for different examples, like if your interest conversion period is monthly, your payment interval is semi-annually, then your C will be interest in the numerator and payment in the denominator. So 12 over 2. In the second case, it is monthly over quarterly, that is 12 over 4, and like that you can find the value of C. Now, here are examples. To attend school, Sam deposits $1,500 at the end of every 6 months for 4.5 years. What is the accumulated value of the deposit if interest is 6% compounded quarterly? So first thing, we need to identify the annuity. So the payments here are done at the end. So you can see the payments are done at the end. So therefore it is ordinary annuity. Now you have to find out whether it is simple annuity or general annuity. You can see the payments are done every 6 months, whereas interest is compounded quarterly. These two are not same, so therefore it is your ordinary general annuity. So ordinary general annuity, so you will calculate what is C, which is the ratio of interest compounding period, that is 4 over payment period, which is every 6 months, so 2. So C value is equal to 2. In case of ordinary simple annuity, it will be always equal to 1 because this 2 will be same and C value is equal to 1. So if C is equal to 1, so it's not a general annuity. If C is other than 1, then it is your general annuity. So you can identify in that way also. So we got the value of C, and then we will find the equivalent rate of interest using this formula. So 1 plus I exponent C minus 1. Calculation of I is the same, 6% compounded quarterly. So it is 0.015. So using this formula, we know this C value, we know the I value, substitute and calculate the P. So you will get the P value as 0.030225. So make sure you calculate the C value till 6 decimal place at least. If N is very large, so you need to calculate the P value even more decimal place, like 8 decimal place. So always it's a good idea to calculate the p-value from 6 to 8 decimal place. N, finding N, so 4.5 years, that is 4.5. So 4.5 years, how many times you are paying? Every 6 months in a year. So 2 times in a year, so it is total 9 payments you will do. Now you can see here, this is your payment period and this is your interest compounding period. Since these two are different, so while calculating the N, you have to make sure you are multiplying it with number of payments. So the years multiplied by the payment period is your total number of payments, especially in the case of general annuity. And then you will substitute in the future value formula, which is FVG. The notation is G for general annuity. PMT you can calculate. What is the PMT here? So he deposits this at the end of every 6 months. So 1500 is the PMT, and 1 plus P, whatever value you got for P, and 9 as your N, minus 1 over P. So there will be no I in the formula whenever it is a general annuity. You can calculate and you will see this is the result. You can also use a financial calculator to calculate it. Now the same way we can calculate the present value, you will use this formula. So you need to just identify the annuity. So the payments are done at the end of every month. Interest is compounded semi-annually. These two are different. So therefore it is your ordinary general annuity. And the problem is a 30-year mortgage on a condo requires payments of $915.6 at the end of each month. If interest is 5.5% compounded semi-annually, what was the mortgage principal? So here it's a mortgage problem, so therefore you need to find the present value. Mortgage principal is the present value. Here PMT is given as 915.60. Since these two are different, so we will find the C value. C value is semi-annually 2 over 12, so which is equal to 1 over 6. And your N value is 30 years. Every year you are paying 12 times. So 30 years times 12, which is 360 times you are paying in total. After calculating the C and I, you will substitute in the formula of P, you will get so the P value. You have to take more than 6 decimal place, that is 8 decimal place, since you can see that N is very big. And after substituting in the formula, the PMT, P and N, you will get the present value. The calculation is the same what we did in the ordinary simple annuity. So you can use the calculator. You can also use the financial calculator. You have to enter the data and then compute PVG. So once you know how to identify the annuity, once you know how to identify future value or present value, and once you have the formula, which formula to use, so then you have to just know how to calculate it in calculator. You are ready to do with the calculator. So suppose for the second problem here, what payment is required at the end of each month for 5 years to repay a loan of $6,000 at 7% compounded semi-annually? So here loan, so it's a present value, and annuity is at the end, so it is ordinary general annuity. Here each month and semi-annually, these two are different, therefore it is general annuity. And I is 7% compounded semi-annually, that is 7 over 2. So we have all the data and we can write it down here. So we have here loan of 6,000, so that is your PVG of $6,000. I is 7% compounded semi-annually, which is 0.035. Your N is 5 years, every month you are paying, so it is 60 times you are paying. And because this is general annuity, you have to find the C, which is interest compounding period, which is semi-annually, divided by payment periods, which is monthly. So you will have C value as 1 over 6. So you can calculate the P as 1 plus I exponent C minus 1. which is 1.035 exponent 1 over 6 minus 1. So calculate till 6 or 8 decimal place and then substitute in the present value formula here to find what is the PMT given at the end of each month. Right, and then for N, you have these formulas to calculate the same rule. Identify the annuity, identify future value or present value, and then identify what is a C, what is a P, and which formula you have to use. So here, suppose first one, for how long must contribution of $2,000 be made at the end of each year to accumulate to $100,000? So accumulate to $100,000, that means it will become 100,000 if you are depositing $2,000 at the end of every year. But how long you have to deposit so that you get $100,000? So $100,000 is your future value here. PMT is $2,000. Your interest is compounded quarterly, whereas payment is every year. So 4 over 1 is your C value. I value is 6 over 4, which is your 3.3 over 2, which is 0.015. And N value you have to calculate. So you will have FVG, P, PMT, and you can find what is the N. So N will give you the number of years for this one because here the payment period is every year and N denotes the number of payments. Otherwise, always how to calculate the number of years. So years is equal to N over payment period. So because in annuity, N denotes the payment period. So N over payment period. Now payment period is here every year. So N itself will tell you the number of years. You can calculate this one. Okay, so same for general annuity due also. So the previous all problems which had the payment period at the end. Now if I am replacing the end by beginning, so that will become the general annuity due. So the process is the same, only the formulas will be different. So you will identify which annuity it is from, whether future value or present value you need to calculate, what are the parameters given, calculate the P and C, and substitute in the formula. So you can try this one, identify which annuity it is from, and then identify what are the parameters given and how you can solve it. So you need to identify, because this is section wise, so of course I have shown this is the future value formula, so then you have to use the future, you need to calculate the future value here, but you can always mix all the problems and try it your own. So this is for the present value formula, and same thing, identifying and then substituting in the formula. So this is a problem of cash value of the lease. So all loan problem, lease problem, cash value of the property, mortgage, all these problems involve the present value. And either you have to find the cash value of the lease, that is you need to calculate the present value, or you have been given cash value of the lease, that means the present value is provided and you need to find either PMT or N or I. Right, so these are the set of problems on future value, present value, then PMT, and then for finding N. The difference here only from the previous one is this is for annuity due, that is the payment is done at the beginning instead of end. Now, the last section of this video, that is perpetuities. So, perpetuities means when the payments are for indefinite period. So, that is called perpetuity. So, for example, the scholarship or the pension amount, once it starts, it ends till the person is alive. Right, so when n tends to infinity or when the payment is done for indefinite period, then it is called as perpetuity. So if it is a scholarship problem or if it is a pension problem, then by default it is a perpetuity. Otherwise, it will be mentioned in the problem that this is a perpetuity. So all these formulas are derived from the previous annuity formulas, where by substituting n is equal to infinity. So these are the formulas for simple perpetuity, general perpetuity, simple perpetuity due, and general perpetuity due. So here are problems. So calculate the amount of money invested today at 6% compounded annually, which will provide a scholarship of $1,200 at the end of every year in perpetuity. So we will identify the annuity first, and because it's a scholarship and it is written perpetuity also, but because it's a scholarship, therefore it's a perpetuity, and the payment PMT is $1,200. Every year you are paying interest also compounded annually. These two are same and the payments are done at the end. Therefore, it is your ordinary simple annuity, and because n is for indefinite period, so therefore it is a perpetuity. So the present value or the amount of investment is your PMT over I, which is equal to $20,000. Same way, what sum of money invested today at 6% compounded quarterly will provide scholarship of $1,000 at the end of each year in perpetuity. So here scholarship is written of $1,000 PMT and 6% compounded quarterly, whereas the payments are done every year. So these two are different, so therefore it's a general annuity. General annuity means you need to find C. C is interest compounding period, which is 4, divided by payment period, which is 1. So 4 over 1. So therefore it is your C value, and you can substitute in the p and calculate 1 plus I exponent c minus 1. You will get the p value, and your present value is PMT over p. So you will get what is the amount invested today, so that you will get a scholarship of $1,000 every year end. So here it ends the perpetuity. You can get the similar problems. You need to just identify which annuity it is from, and you will have the perpetuity formulas, and you can just identify the parameters and substitute in the formulas. Thank you.